In this video, we'll be able to model and solve a situation using quadratic equations, and we're specifically going to be looking at using the factoring strategy to solve these quadratic word problems. So the easiest way to actually solve these is to kind of dive in, read the instructions, and draw a picture. So that's what I'm going to do here. So this is saying that you have made a quilt that is 4 feet by 5 feet. So I'm going to draw my quilt here, and I'm going to label it. So I'm going to say, you know, this is my 5 feet side, and this is my 4 feet side. And it says you want to use the remaining 10 square feet of fabric that you have to add a decorative border of uniform width. Now, that might seem a little bit tricky, but essentially what it's saying here is that it wants to add a border around it that extends the same amount around the entire thing. So our border is essentially going to look like this. So you can see how I extended it out that amount the same way in each direction. And so the tricky part is here that we're trying to find the width of the border. And so because I don't know what that is, I'm going to label that as X. So essentially what's going on here is we have the quilt in red, and our goal is to essentially add on 10 square feet of fabric around the outside in some capacity, so it's a nice uniform border there. Now, I think these are a little bit tricky, so what I like to do is, instead of trying to piece together, okay, exactly what is the area of just the part between the red and the blue, I like to look at this as a whole. And so what I'm looking at here is I see in blue that I have a really big rectangle. And so I'm going to try to figure out what are the dimensions of this really big rectangle. Well, the side of this really big rectangle over here is the 4 from the red plus an X on either side of it. So really that line I just drew in purple, that side length is 4 plus 2x in length. That's 4 feet plus 2 times whatever the border width value is on either side. Then from here, if I do this side here, this side over here is the 5 feet from right here. So I have 5 plus an x on the top and an x on the bottom. And so this is really 5 plus 2x. And so I have this really big rectangle with both the border and the quilt included. And what I'm going to try to do is I'm going to try to use my knowledge of area and math to figure out what x needs to be. Now, I know that in order to calculate the area of this entire thing right here, and we'll keep that in blue, in order to find the area of this entire piece right here, we have to take length times width. And so our area here is going to equal our length, which is the purple side of 4 plus 2x. And I'm going to multiply that by the width, which is this side right here, of 5 plus 2x. So notice I'm taking length times width to find area. Now, it might not seem so obvious, but we actually know what the area of this entire rectangle is, because we know that this square right here, this 4 by 5, is calculated by taking 4 times 5, so this area right here is 20. And then if I think about it from the instructions, I know there were 10 more feet, and that area right there is 10 all around the side. So if I add those two values together, my area is the 10 around the outside plus the 20 on the inside, and so I really have an area of 30. So I have 30 equals 4 plus 2x times 5 plus 2x. So that's the area of that really big rectangle there. Now what I'm going to do here is I'm going to multiply this all out and then use my factoring strategies to help me actually solve it. So I'm going to start here. We're going to distribute to try combining some terms together. So I have 4 times 5 is 20. 4 times 2x is 8x. And then I have 2x times 5 is 10x, and 2x times 2x is plus 4x squared. And then there's still this 30 over here. So I'm going to combine some things together on this left-hand side and write it in descending order. So I want that 4x squared first, and then I want the x's together second, and then I have that plus 20 on the end. Now I know that if I want to use factoring here to solve this, I'm going to need the zero product property and it equal to 0. So I'm going to subtract 30 from each side to get that equal to 0 piece. And so when I do this, I now have 0 equals 4x squared plus 18x minus 10. And this is now ready for me to factor. So what I'm going to do is I'm going to start, like I always do, with factoring out a greatest common factor first. While these do not have a variable in common, they do all have, they're all even numbers, and so they are all divisible by 2. So I'm going to factor out a 2, and I'm left with 2x squared plus 9x, and then minus 5 there. So now I need to look and see if another factoring strategy applies to here. I'm going to look at my ABC values. So I have A is equal to 2, B is equal to 9, and C is equal to a negative 5. So I need two numbers that multiply to be A times C, which is negative 10, and add to be 9. And if I think through those factors, I know that 10 and negative 1 are my only combination. So here I can rewrite this as 2x squared plus 10x minus 1x minus 5. Group them in pairs, so I have greatest common factor of 2x here to get x plus 5. Factor out the negative 1 here to get x plus 5. And then from here, I have my equation, which is 2x minus negative 1 grouped together, and then the x plus 5 together off to the side, and then remember this 2 carries all the way down. So I've now written this into factored form, and so now what I need to do is I need to solve this equation by setting each little part equal to 0. So here I'm going to come up here, start by setting 2 equal to 0, but I see that's not helpful because there's no variable there, so that's not going to help me find an answer. We have 2x minus 1 equals 0, so if we add 1 to each side, we have 2x is equal to 1 divided by 2. So that's saying x is equal to 1/2 of a foot, which seems like a pretty feasible option. That'd be about 6 inches. And then we also have x plus 5 equals 0, so if we subtract 5, we have x equals negative 5 feet. Now, if I look at these two answers, the answer that doesn't make sense is negative 5. You wouldn't have a negative length of a border. So here we can say that our x value, or our border width, which we can see up here back in our picture, our border width of the border that goes all the way around that quilt is 1/2 of a foot, or 6 inches wide. So let's take a look at a second example. This one says you trimmed a very large square photo to fit a frame. So what I notice here is that if this has a square, while I might not know the dimensions of this entire picture, since it's a square, I know that each side length has to be the same. So we're going to kind of keep that in mind as we go. Side length has to be some sort of side length. We don't know what it is. Then it says you trim 6 inches from the length and 5 inches from the width. So essentially what we're doing is we're taking this picture and we're trimming it back 6 inches. And then we're also trimming, 5 inches from the width. So we're trimming maybe, 5 inches this way. So essentially we're making this picture a lot smaller. We're trimming 6 inches here, so that's gonna come off. And then we're trimming 5 inches here. Okay, it says the area of the resulting photo after being trimmed is 20 inches. So it's saying this area right here of what is left is 20 inches squared. So we trim 6 inches off on this side, and then we trimmed, we'll do 5 inches in a different color off on this side, and we're left with that 20 inches squared photo off to the side that is left. So that's how we trimmed it. Now it's saying, what is the length of a side of the original photo? So what we're going to do is we're going to kind of work backwards. Since we know the area of this little rectangle here, we're going to start to think through, okay, what are the side lengths of each side of that rectangle? So on this side right here, I know that I trimmed off 6 inches. So this side from here to here, it's going to be whatever the original picture length was, which is x, minus the 6 inches we trimmed off of it. And then going the other direction, this one right here, this is the original side length we had, right, which was X, but we trimmed 5 inches off of it. That's how it got smaller. So this triangle, or this rectangle that we're seeing right here, takes a side length, chops 6 off, takes a side length, chops 5 off, and it equals an area of 20 inches. So let's write that into an equation. We have area equals length times width. Here my area is 20, so I'm going to fill that in. I then have a length of x minus 6, and then I have a width of x minus 5. And so now let's multiply this out and work on solving it. So here we're going to multiply x times x, which is x squared. We have negative 5x, negative 6x, and then positive 30. And that all equals 20. Then I can combine some like terms. So I have x squared minus 11x plus 30. That still equals 20. Now, if I'm going to use any factoring strategies to help me solve this, I need to get this set equal to 0. So I'm going to subtract 20 on each side. So we have 0 is equal to x squared minus 11x. And then 30 minus 20 is a positive 10. So we now have something that we can actually factor and solve. When I look at this, I see that a and c are not both perfect squares, but I have an a value that's equal to 1, a b value equal to negative 11, and a c value equal to 10. So if we multiply a times c, we need two numbers that multiply to 10, and then add to b, which is negative 11. And if I think through what two numbers multiply to 10 and add to negative 11, I come up with negative 10 and negative 1. So here I'm now going to work on factoring this. So I have x squared minus 10x minus 1x plus 10. I used those two numbers to help me. I then group these in pairs, so I factor out an x, because that's all they have in common. So I have x times x minus 10. To get the same parenthesis part, I now factor out a negative 1, and then I get x minus 10 left on the inside. So I'm left with x minus 1 grouped together in front, and then I have x minus 10 as well. Now, if you looked at this and noticed, hey, a is equal to 1, you also may have just been able to take those two numbers and jump right into your factored form quickly if you remembered that little trick. So finally, I need to take these two numbers and I need to set them equal to 0. So we have x minus 1 could equal 0, or x minus 10 could equal 0. And so here we add 1 to each side. So this is saying one option is that its original length was x equals 1 inch. Or our other option is that x is equal to 10 inches. And now remember, because this was talking about a side length here, it's talking about this side and this side of a picture, we can't take 1 inch and, trim 6 inches off of it, or trim 5 inches off of it. And as a result, this answer right here doesn't make sense. So what we can say is that this picture originally started off to be 10 inches by 10 inches. Then we trimmed 6 inches off on one side and 5 inches off on another. And it eventually became a 4-inch by 5-inch picture that results in that area of 20 inches squared.